I've got my Aloha shirt on and I comb my hair, so I am ready for this super awesome, important video about
the battle for your soul.
It's really easy for me as an artist to divide my life into art and tech, and I'm hoping that I can show you why it may not be as clear a dividing line as we'd like to think. And the way I'm going to do that is by showing you this incredibly technical build for the Kiln on one hand, this microprocessor control, and a little bit of the wizardry that's involved in controlling a high-power device like a Kiln. And I'm also going to be showing you how I worked with the clay to make the things that I'm going to put inside this Kiln. It's really easy for me to lump this Kiln controller in the tech category and clay making into the art category, but the distinction is actually not that obvious. While I'm building the Kiln controller, which is the tech, there's a lot of artistic decision making involved in that process. And while I'm building clay, it looks like I'm just goofing around and playing with something, but there's actually a lot of tech in pottery, and I'm starting to get a feeling for that as I do these cups. So stick around while I show you how I built this Kiln controller and finish up with these beginning cups. Many of you may not have seen the first part of this video where I get the Kiln and go in and design this Kiln controller, because this is part 2. I think it's a great topic and it gets into the battle really for the human psyche, for your soul. And there's a lot there that you can get your hands dirty with. So I encourage you to stick around for the future parts by hitting that subscribe button. All right, so I've run into a hurdle, so I'm going to physically move a pin for the first time. So I'm going to move it from 19 to 9. You might be surprised to see me back here again, but I screwed up. End of day, I think it's 3. But this is it running. You can see the SSR light, that's a solid state relay light, is blinking. And that means it's activating the elements to go on and off. So it's gonna be pulsing the elements, and it's attempting to reach 50 Celsius, which is about 20 degrees Celsius warmer than it is right now. So at the end of the day, there were a lot of issues with that I was running into, but a lot of it was just pins. Like the alarm pin was set to like 26 or something, and I guess that was screwing something up. I've set this up as a headless. I had to do a bunch of coding. It wasn't up to my standards of code, which are pretty high. I was having an issue with this just random crash. I've spent almost a day or two troubleshooting this glitch, but I finally figured it out. So I know exactly what's going on, and I'm pretty sure I know how to fix it. I need one piece that's coming, and then I've got another couple pieces that I want to improve this spaghetti here of wiring. I don't care about the spaghetti, I just care that it's a spaghetti of 6 AWG wire. It's like handling copper pipe. And then I've got the fix for this bug, which I'm about to go into right now. Here is the home page, and I've got a program list. Now I have put this very short test program so I can load it up, and then I can see the chart, and then here at the bottom you can see that I can start the program, and the start usually works, but the finish will crash most of the time. So, but it'll still sound cool and you'll still see everything that's happening. So I'm gonna hit start. Oh, come on, that's pretty sweet, right? So start is activating the main contactor. We should see some blinking. Oh no, so it crashed. Like I said, it crashes sometimes. So, okay, let me load the program again. All right, and then let me hit start. Okay, so that's crashed, unfortunately. So, I mean, you're getting a little glimpse at what I was doing for the last 2 days. Try that again. Oh, it's crashed again, man. Oh, okay, hallelujah. So it's actually, it didn't crash on start, which is good. So it should be doing its thing with the relay, I'm hoping, but let's see. All right, it's running. I had made some changes, broken the PID function. I reverted, and solid state relay here is now being activated, which is what it should be doing. So that's actually switching on and off this 50 amps worth of element, and at the end of this cycle, so into what the critical malfunction is, that when the program ends, so now it's crashed. So that's the issue that I've been trying to debug for the last couple of days. I was eyeing the web server thinking that there's something asynchronous happening and some kind of a memory fault. If I disconnect the main contactor, everything works flawlessly. So the issue is that there is inductive kickback coming from this coil in this contactor, and I think that it's blowing all the way past the relay and somehow affecting the power supply of the actual Arduino. That's the problem. So in order to solve that, I'm ordering something called a little scrubber, and it's going to prevent it hopefully from doing that kickback. All right, so we should be able to finalize this build now. There were a lot of things that I was not that happy with, and there are some new things. So I'm just going to show you what those are. One of the things that's annoying when working on this box is the inability to easily remove the thermocouple. So I need to slice this wire, and I'm going to insert a panel mount thermocouple plug here instead of that thing, so that I can easily pull the thermocouple for maintenance, and etc., etc. I need to install a power switch, so I'm going to put this guy across the terminals and then wire these guys up so I can turn it on and off. And I've got the new contactor here, which is both sides normally open rather than one normally open, one normally closed. It's also much more highly rated. It's 100 amps, so should be better. One of my favorite upgrades is going to be this bus bar. This is the snubber circuit that finally fixed the crashing issue. This is the thing that finally stopped this relay from kicking back. All right, so I guess it's probably a good idea to do a little side by side between the old and the new. This is much cleaner. We don't all have this spaghetti of wires, which was this junk, which I absolutely hated. So I took that out and I put the bus bar. Look how clean that is. Now we've got the red side going to the left pole and the black side going to the right pole. And that bus bar is spreading it across all the breakers, which is beautiful. We've got the new switch, and we've got the thermoprobe plug there. The snubber circuit is encased in self-sealing silicone tape. Just looks a lot tidier. Okay, so by this point, the hardware is done, and I started to look at the software side of things. And I'm just going to summarize what happened here because it really took a long time. And if you look at the screen recording here before and after, The difference here is about 4 days of me getting to the bottom of why this PID kiln controller software just wasn't really very good. Now, there were several issues with the architecture of the program. The way that it did something called the PID loop was not good in my opinion, so I updated that. Now, above and beyond that architectural decision, the main flaw with this code as it was the core code of the PID algorithm. Now, PID means proportional, integral, and derivative. And I think the simplest way of describing those three things is that P means how much heat should I apply depending on how far I am away from the target. The I part is what kind of mistakes have I made in the past that I now need to account for. The D part's going to be a lot easier if you know a little bit of calculus because it's the derivative, which is the slope, which is how quickly am I getting to where I want to go, and should I adjust based on that velocity. So I'm not going to get too deep on this, but suffice it to say that with something like a kiln, one of the most problematic parts of this is actually the integral part, because this kiln is extremely slow to heat up. So that error piece of the equation can build up to the point where it starts creating a springing effect when you get to temperature, and we don't want that. So I use something called a proportional integral, which means we don't even start looking at that error until we're close or at the set point. So in the end of the day, I had to actually pull out this standard PID algorithm and I wrote my own. It's really a very simple algorithm. In the end, what I got worked really well and actually brings the kiln perfectly up to temp and then holds it there. I won't be able to fully test it until I'm actually at the temperatures that I want to fire at, so that's coming up. But the next part of this was actually making something to put in the kiln, and so here I am, and I'm making a cappuccino cup. I only have a latte cups, and I've decided that I want smaller cups for cappuccino. Okay, so idea now is to do a pinch pot, basically. All right, so I think I've got a new strategy here, which let me re-wedge this again. This feels like the right way to do it here. I'm kind of shaping the base here so that I have a good base. It looks more like a bowl than a cappuccino cup. It's too big at the base, so I think I stretched the base out too much. All right, we're going to start again. I'm just going to spread it as evenly as I can. See, that's about the amount that would hold an espresso, so it's way too thick for an espresso cup. So let's see how big. I think we just need to get the amount of clay correct. I think it's a fun size cup. I realize that this is not a very efficient way of making this thing, but I am not about efficiency at this point anymore, about anything. I don't want efficiency anymore. I think the age of efficiency has gotten us this far, and now we have to go back to being extremely inefficient about everything that we do. So I propose we just do a best effort to make an all-in-one cup here. Perfect. Okay, so we're going to try this, and we're going to see what happens. All right, I'm not going to overwork it. I think that's pretty good right there. Right side up to dry or upside down? I really don't know. Daughter says I should dry it like this. All right, I'm going to make another one now. And this time I don't want it to be so wide. I can see why a wheel becomes so tempting. I feel like this would be way easier to accomplish on something that was turning quickly. But I don't have a wheel. I don't want a wheel. I want these to be clunky and quirky. So I don't really care about a wheel. Also, I'm getting really quite fast at this. All right, that's 2 cappuccino cups. Finished. All right, this cup has dried overnight, so it's ready to be slightly worked on. And again, I'm reminding you that I have no clue what I'm doing. But according to my daughter, now is the time to smooth this out. So my idea is just to try to get some of these larger lumps out without spoiling the cup. Even it out a bit. Okay, another cup done. We're gonna let that dry up. All right, time to wrap this up. Next time I am going to be firing some stuff in the kiln, which means I need to tune the kiln to make sure that it holds temp properly. And I'm also going to make a lot more things to put in the kiln. Right now I've got the 4 cappuccino cups. I'm gonna add some other stuff to that, maybe some espresso cups and maybe some macchiato cups and maybe one special cool surprise thing. So make sure you hit that subscribe and I will see you in the next one.